Hello, good day everyone. We are now in topic 12 of our basic calculus subject, which talks about techniques of anti-differentiation. The competency. At the end of this session, you are expected to compute the antiderivative of a function using substitution rule. Antidifferentiation is more challenging than differentiation. To find the derivative of a given function, there are well-established rules that are always applicable to differentiable functions. For antidifferentiation, the antiderivatives given in the previous lesson may not suffice to integrate a given function. A prerequisite is knowledge of the basic antidifferentiation formulas. Some formulas are easily derived, but most of them need to be memorized. So, kinahanglan jud i-memorize ang mga formulas. No hard and fast rules can be given as to which method applies in a given situation. In college, several techniques such as integration by parts, partial fractions, trigonometric substitution will be introduced. This lesson focuses on the most basic technique, anti-differentiation by substitution, which is the inverse of the chain rule in differentiation. There are occasions when it is possible to perform difficult piece of integration by first making a substitution. This has the effect of changing the variable and the integrand. The ability to carry out integration by substitution is a skill that develops with practice and experience, but sometimes a sensible substitution may not lead to an integral that can be evaluated. We must then be prepared to try out alternative substitutions. We can transform the given into another form by changing the independent variable, for example x, to another variable u using the substitution. This change of variable is one of the most important tools available to us. This technique is called integration by substitution. It is often important to guess what will be the useful substitution. Usually, we make a substitution for a function whose derivative also occurs in the integrand. Example number 1. Evaluate the antiderivative of quantity x plus 4 exponent 5 dx. Okay, in this case, we are going to let quantity x plus 4 be equal to u. So that's why the given now becomes the antiderivative of u to the fifth du. which is similar to u of 5 plus 1 all over 5 plus 1 plus c, which is similar to u exponent 6 over 6 plus c. And since u is equal to quantity x plus 4, so we replace it again, so to the 6 all over 6 plus c. So therefore, this will be our final answer. Quantity x plus 4 to the 6 all over 6 plus c. Okay, by the way, in this case, the derivative of u here is equal to 1, which is equivalent to the derivative of x, diba? So, du is equal to dx. So, muna ang dx, ipulihan na nato og du. Okay? In example number 2, we are going to find the antiderivative of quantity x to the 5th plus 2 exponent 9 5x to the 4th dx. Okay? If we are going to let u be x to the 5th plus 2, then the derivative of u is equal to, derivative sa u is 5x to the 4th dx, right? So therefore, ang 5x to the 4th dx can be replaced with du, and this one can be replaced with u. So this will be the same as u to the 9th du. Okay, so finding the derivative, so it should be u to the 9 plus 1 is 10, u to the 10 over 10 plus c. Okay, so replacing u with this one, so we can now have quantity x to the 5th plus 2 to the power of 10 all over 10 plus c. So therefore, the antiderivative of quantity x to the 5th plus 2 exponent 9 5x to the 4th dx is equivalent to quantity x to the 5th plus 2 to the power of 10 all over 10 plus c. Okay, number 3. We are going to find the antiderivative of g squared all over the square root of 1 plus z cubed dz. Okay, so for number 3, we are going to let u be equal to 1 plus z cubed, and from there we can find the derivative of u, which is equal to 3z squared dz, in which we can say that ang 3 dz it should be g squared, ang atong kuanon kay g squared dz man ni diri, no? So dapat z squared dz is equal to divide both sides by 3, so manang mahimong 1/3 du. Okay, So from the given antiderivative of z squared over the square root of 1 plus z cubed dz, this can also be written as the antiderivative of 1 over the square root of 1 plus z cubed times z squared dz, which is ang kani will be the same as the antiderivative of 1 over square root of u, and this one is equivalent to 1/3 du. Okay, which is similar to 1/3 antiderivative of u to the negative 1/2, because u here has the exponent of positive 1/2, then ato namang ipaibabaw si ja, so mahimo dyang negative 1/2 du. Okay, and getting now the antiderivative, so it should be equal to 1/3 times di klaro 1/3 times u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. Okay, so simplifying the exponent, we have negative 1/2 plus 1 is equivalent to u to the 1/2 all over 1/2, then plus c, which is equivalent to 1/3 times u to the 1/2 times the reciprocal of 1/2, which is 2, plus c. So it should be similar to 2/3 u to the 1/2 plus c. And i-replace na to ang u with the original value, original binomial, which is 1 plus z cubed. So it should be equal to 2/3 quantity 1 plus z cubed to the 1/2 plus c. Okay, or kato ni iuli sa square root, it should be 2 square root of 1 plus z cubed all over 3 plus c. Okay, that's number 3. Okay, number 4 is we are going to evaluate the antiderivative of x over x squared minus 1 dx. Okay, in this example, we are going to rewrite the given as the antiderivative of 1 over the square root of x squared minus 1 x dx. Okay, if we let u be equal to x squared minus 1, this would imply that the derivative of u is equal to 2x dx. Okay, and kung magpurma tag x dx, we are going to divide both sides by 2. That's why x dx is equal to 1/2 du. Okay, so substitute na to dere. We have the antiderivative of 1 over the square root of u times 1/2 du, which is, we can rewrite this one as the antiderivative of u to the negative 1/2 du, which is 1/2 of the antiderivative of u. The antiderivative of u to the negative 1/2 is similar to u to the negative 1/2 plus 1 all over negative 1/2 plus 1 plus c, which is equivalent to 1/2 times quantity u to the 1/2, because negative 1/2 plus 1 is 1/2, over 1/2 plus c, and we can simplify this as 1/2 u to the 1/2 times the reciprocal of 1/2, which is 2 over 1 plus c. So we can cancel 2 and 1/2. So i-replace na to ang u with the value ng atong galat ganina. So it would be x squared minus 1 to the 1/2 plus c, or that would be equivalent to the square root of x squared minus 1 plus c. Okay, that's number 4. And number 5, we have the antiderivative of x cubed over the square root of x cubed plus 5 dx. Okay, number 4, we are going to let u be x cubed plus 5. And in this case, since x cubed man ang numerator, x cubed could be equal to, gikan dire atong i-transpose si 5 to the left, so x cubed is the same as u minus 5. Okay, so that's why the antiderivative of x cubed over the square root of x cubed plus 5 is similar, tx is similar to the antiderivative of u minus 5 over the square root of u dx. Okay, and notice that it would be similar to the antiderivative of u minus 5 over u to the 1/2 dx, which can be simplified to the antiderivative of quantity u over u to the 1/2 minus 5 u to the 1/2 dx. Okay, after that, it is similar to the antiderivative of u times u to the negative 1/2 dx minus the antiderivative of 5 u to the negative 1/2 dx. Okay, so getting the antiderivative of this one, we can simplify pa di ay, di sa natukuhaan. Combining, so we have u to the 1 plus negative 1/2 is 1/2 dx minus 5 antiderivative of u to the negative 1/2 dx. Okay, getting now the antiderivative. So this would be similar to u 1/2 plus 1 over 1/2 plus 1 minus 5 times quantity. The antiderivative of this is u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. So simplifying, 1/2 plus 1 is u to the 3/2 over 3/2 minus 5. U negative 1/2 plus 1 is u to the 1/2 over 1/2 plus c. And this can be simplified to the reciprocal of 3/2 is 2/3, so 2/3 u to the 3/2, and kanipod the reciprocal of 1/2 is 2 times 5 is negative 10 u to the 1/2 plus c. So replace na to ang balik og u with x cubed plus 5. That's why we can now have 2 over 3 quantity x cubed plus 5 exponent 3/2, then minus 10 quantity x cubed plus 5 to the 1/2 plus c. Okay, so that's the final answer for number 5. Number 6. Evaluate the antiderivative of dx over x cubed square root of ln of x dx. Nanay dx ha. Okay. Okay, ang idyang x is naa din ha sa numerator. Ang dx ni dyan na sa denominator, sa numerator. Okay. If we are going to let u be ln of x, then we can say that the derivative of u is equal to 1 over x dx. So, recall sa atong mga formula. So, ang given can be written as 1 over the cube root of ln x times 1 over x dx. Diba? Kanto atong ibuwag ha. So that we can replace this one with u, so the antiderivative of 1 over the cube root of u times du, which is similar to the antiderivative of u to the negative 1/3 du. So, getting the antiderivative, we can now have u to the negative 1/3 plus 1 all over negative 1/3 plus 1 plus c, which is similar to u to the 2/3 over 2/3 plus c. And getting the reciprocal of the denominator, so we can now have u to the 2/3 times 3/2 plus c. So it should be 3/2. No, 3/2. No, not 3/2 u to the 2/3 plus c. Replacing the u with its original value. So therefore, the final answer would be 3 over 2 quantity ln of x to the 2/3 plus c. Okay? Then we have theorem 14 stating the theorems on integrals yielding the exponential and logarithmic functions. That we have the antiderivative of e to the x dx is e to the x plus c, and then the antiderivative of a to the x dx is equal to a to the x ln of a plus c, where e to the x over ln of a plus c, hence a is greater than 0 with a is not equal to 1. And the third one is antiderivative of x to the negative 1 dx is equal to antiderivative of 1 over x dx is equal to ln of the absolute value of x plus c. Humana ni ganina sa atong previous lesson. So we are going to use this one in answering example number 7. Okay, in letter A, we have the integral of e to the 3x dx. Okay, in this case, if we let u be equal to 3x, our derivative of u is equal to 3 dx. And from here, we can say that dx is equal to du over 3. Okay, so if we are going to rewrite this one, we have the antiderivative of replacing the 3x with the u, we have e to the u times dx is du over 3. Then we can simplify it as 1/3 of the antiderivative of e to the u du. So in here, the antiderivative of e to the u or e to the x dx is e to the x. So it should be 1/3 of e to the u plus c. So that's why replacing the u with 3x, it should be equal to 1/3 e to the 3x plus c. Okay, so mo na final answer. Okay, for letter B is the antiderivative of 2 to the 4x dx. So if we let u be equal to 4x, du is equal to 4 dx, and dx is the same as du over 4. So we can rewrite this one as the antiderivative of 2 to the u, and dx is du over 4. Okay, then this can be simplified as 1/4 the antiderivative of 2 to the u du. So using sa theorem number 2, it would be similar to 1/4 times the antiderivative of 2 to the u is 2 to the u over ln of 2 plus c, which is similar to 1/4 times the u here is 4x, so 2 to the 4x over ln of 2, then plus c, which is equivalent to 2 exponent 4x over 4 ln of 2 plus c. Okay, and for number 3, or letter C, we have the antiderivative of 1 over 2x minus 1 dx. If we let u be 2x minus 1, so the derivative of u is equal to 2 dx. So dx is equivalent to du over 2. So replace na to ni og u. So ang given now becomes 1 over u, and then dx will be substituted with du over 2. And this would be equivalent to 1/2 antiderivative of 1 over u du. Using the third or number 3 of the theorem, this would be similar to 1/2 ln times ln of the absolute value of u du. So, you replace na to ang u with 2x minus 1. So, it should be equal to 1/2 ln of quantity. No, dili na ni Dio, pataka na ko. Kanang L plus C na ni. Nag-Dio pa man ko. ln of 2x minus 1, ln of the absolute value of ln, 1/2 of ln of the absolute value of 2x minus 1 plus c. Okay, so that's number 7, letter C. So since more hintaas naman, ato sa ning put doon, ang example 8 to 17 will be adto na sa sunod na pod na tong video, ha, kay kanang taas na kaadyo, so aron di kaadyo kapoy sa inyong pananaw. So that's all for this, and we will continue example number 8 up to example number 17 in the next video. Thank you, and continue to watch our discussion para mas makasabot mo. Pero kung di na mo na kinahanglan, it's okay. Sige, thank you and God bless.